Hi guys, welcome to today's video. This is 2018 paper 2 question 3 involving some probability and an interesting twist with the factorials as well, so let's get into it. Here's our question, question 3. A security code consists of 6 digits chosen at random from the digits 0 to 9. The code may begin with 0 and digits may be repeated. For example, 071737 is a valid code. And we're told to find how many possible codes will end with 0. Okay, so I was glad when I saw this on my leaving cert because, you know, this is just a simple permutation. You're going to see these all the time. So for the first digit, we've got 10 options, and that continues up until the very last digit, which must be 0. So to put that down now in part 1, it's going to look like this. So essentially, we've got 10 options for the first digit, 10 options for the second digit, and the only digit which our options are restricted on is going to be the last digit, which must end in a 0. So that's actually just going to be our number, which we can simplify to 10 to the 5. So that's the number of possible codes which will end in 0. And for that part of the question, you'll actually get a massive 15 marks. So, you know, quite a lot of marks going for something that I consider quite simple, which is good to know. Okay, now, so we're asked to find how many of the possible codes will contain the digits 2, 0, 1, 8 together and in this order. So we need to make sure they're in that order. So the best way to think about this part of the question is to just treat 2, 0, 1, 8 as a digit in and of itself. So just to treat it as one big digit, because that's going to make it easier to consider. So essentially what this means is we need to fit this in at the start, somewhere in the middle or at the end. So if we fit it at the start, it's going to be like this. So we have one possibility for the first 4 digits from 0 through to this 7 here, for example. And the last 2 digits will vary. So we've got 10 options at the second last digit and 10 options for the last digit. So that's one way to do this. The second way is to first of all have a random digit at the start. So for example, you know, in this position here, and then have 2018 in the middle, the next 4 digits, and then have the last digit be random as well. So that's our second possibility. And lastly, we just have the possibility that we make the first 2 digits be any random digit from 0 to 9. And we're going to have the last digit or the last 4 digits be 2018, which will give us exactly what we're looking for. So we just need to add all those together now, which will give us 3 times 10 times 10, which means that our answer is 300. So that's the number of possible codes that will contain the digits 2018 together and in that order. And you have to remember to look out for that as well. That's a key word that needs to be in this order because it will add further complexity if it wasn't to be that way. So if we're doing this part of the question, which is, you know, would also consider quite nice, you're going to get 5 marks. So now for part B, we've got something a bit different. We've got a given sort of fraction here. We've got to find A, B, and C, and D. If we're given this fraction and an cubed plus bn squared plus cn plus d is equal to that. So we're told that they're all natural numbers. Let's just first of all write out what we're already given. So we're dealing with factorials here, so we need to find a way to just simplify this fraction to cubic. So our first step is just going to be to rewrite this slightly because we know that n plus 3 factorial is going to be n plus 3 times n plus 2 all the way down to 1. So let's just rewrite this a little bit into the following. So just treat these like any other number. So like for example, if n plus 3 was equal to 10, you would have 10, 9, and 8, and then, you know, n plus 1 is going to be 8 factorial. So it's just have to think about these as numbers so that we can cancel them out. So when we write them this way, you know, it's just going to be n plus 1 factorial on the bottom and top twice. So we can cancel that and over there as well. So we're left with n plus 3 times n plus 2 times n plus 2. And this question sort of relies on a pretty deep understanding of factorials. So you should probably practice a few of these in case it does come up. So now we've got 3 factors of a cubic and we just need to multiply them out. Okay, so when we expand that out, because we have n plus 2 twice, we're going to get n times n plus 2 times n plus 2 plus 3 times n plus 2 plus n plus 2. So times n plus 2 I should say, to this now. So we've got a quadratic now in both brackets and we just got to multiply the n and 3 in. So now we've got a cubic and we just need to simplify down so that we have n cubed plus n squared all nice and neat all together in order to find our coefficients. So now we've got n cubed plus 7n squared plus 16n plus 12, which means our a, b, c, and d are just going to be these numbers. So because 1 is the coefficient of n cubed, which obviously isn't there, but we can assume that. 7 is the coefficient of n squared, and 16 is n, and 12 is our constant. So those are the values of a, b, c, and d. And it's kind of hard to believe for all that work that you're only going to get 5 marks. So that's the perfect example of a top-heavy American scheme, which you're going to see quite a lot if you look at the American scheme. But that's it for part B, and the hardest part of that was definitely cancelling down your factorial and just remembering to then follow the rules of expansion and just do that nice and slowly. So that's it for this question. I hope you enjoyed the video. If you did, there's going to be other similar videos in the description, as well as other resources that might help you out if you're feeling stuck. And I'll see you next time.